Okay, here's a question to start us off.
Yeah.
What if you, actually fell into a black hole?
Wow, yeah. Straight into the deep end.
Right. It's terrifying, but also, weirdly fascinating. That quantum wisdom video we watched called them some of the scariest, most mysterious things out there.
Absolutely. And that's exactly what we're going to dive into today. Using that video as a kind of guide, we're going to try and unpack what might really happen if you took that plunge.
Yeah, forget just the complicated maths for a bit. Let's talk possibilities, because it sounds like it's not just about being, obliterated, is it?
Not necessarily, no. There are all these mind-bending ideas about time, space, even other universes potentially being involved.
Okay, so this deep dive is basically a trip into the unknown, exploring what falling into a black hole could be like. Maybe even something bizarre.
Could be. So the video sort of laid out the stages, right? First, you get near the event horizon.
The point of no return.
Exactly. Then there's spaghettification. Sounds delightful.
Doesn't it just...
After that, you face the singularity itself. And then we get into the really speculative stuff, like firewalls or maybe even white holes.
Quite a journey, then.
Yeah.
Okay, let's start there, at the event horizon. The video made it sound, very final. What actually is it?
Think of it as an invisible boundary. Once you cross it, gravity's pull is just too strong. Nothing escapes, not even light. It's the ultimate one-way ticket. But, and this is the really weird part, your experience crossing it would be totally different from someone watching you from, say, a safe distance.
Right, okay, the video mentioned this. This is a real head-scratcher. So if someone's watching me fall in,
yeah,
what do they actually see?
Well, from their perspective, as you get closer and closer, time for you seems to slow right down, like it stretches out.
Stretches?
Yeah, you'd appear to move slower and slower until you look like you've just frozen, right there at the edge.
Frozen, but I'm still falling.
In your reality, yes, but to them, you're stuck. And the light from you gets stretched too, making you look redder and fainter. It's called red shifting. So they never actually see you cross. You just kind of fade out into this frozen, reddish image.
That is just bizarre. So I'm falling, but they see me stuck forever. Okay, so what about me? What am I feeling as I, drift across this line?
From your point of view, nothing special, actually. As you cross the event horizon itself, there's no sign, no feeling, no big event. Time feels perfectly normal.
Really? No jolt or anything?
Nope. It'd be like walking through an open door you didn't know was there. You just sail right through, completely oblivious to how utterly strange you look to the outside universe. It really shows how gravity messes with space-time.
Okay. So I'm past the point of no return, feeling fine for now.
Yeah.
But then the video brings up spaghettification, which sounds less than ideal.
Yeah, less than ideal is putting it mildly. Spaghettification is what happens because the gravity is so much stronger at your feet than at your head, assuming you're falling feet first.
Oh, right, the difference in pull.
Exactly, an incredibly steep difference. This tidal force literally stretches you out lengthwise while squeezing you from the sides.
It's like spaghetti, hence the name.
Precisely. And the video mentioned this happens atom by atom. You're literally elongated into a thin stream of particles.
Atom by atom. Wow, that's vivid. Does it happen instantly?
Well, it depends on the black hole. For smaller stellar mass ones, yeah, pretty much. The tidal forces are immense even before you get really close. You'd be shredded quickly.
Yep.
But for the supermassive black holes, the ones in galactic centers, the event horizon is much bigger, and the tidal forces at the horizon are actually weaker. So you might survive crossing it intact for a bit longer.
A bit longer before being turned into human pasta. Lovely.
The end result is unfortunately the same. Eventually, you get stretched.
And at the end of this stretching process is the singularity. The video called it the end of space and time. Sounds pretty final.
It's a good way to put it. Theoretically, the singularity is the black hole's core. All its mass is crushed into a point with zero volume, infinite density, infinite gravity.
Infinite.
Yeah.
My brain just kind of stalls trying to picture that. Zero volume.
Yep. It's where our current physics, like Einstein's general relativity, stops working. It describes it as a point where space-time curves infinite. The rules just break down.
But hang on. The video then brought up quantum mechanics, saying information can't just be destroyed. How does that square with being crushed into infinity?
Yes. That's the big problem, the black hole information paradox. If you and everything that falls in gets crushed into the singularity, what happens to the information that made you you? Quantum mechanics says information can't be erased.
So it's a direct clash between gravity theory and quantum theory.
Exactly. One says you're obliterated. The other says the information about you must survive somehow. It's one of the biggest puzzles in physics today. Where does the information go?
Which I guess leads to some of the more, wilder ideas, like the firewall hypothesis. That sounds bad.
It does sound pretty intense. The firewall is a more recent and, yeah, pretty controversial idea. Some physicists proposed it as a way around the information paradox. It suggests that maybe the event horizon isn't smooth and empty like Einstein thought. Maybe it's actually a ring of incredibly high-energy particles, a literal wall of fire.
So instead of spaghettification, instant incineration.
Pretty much. Anything trying to cross hits this firewall and is just vaporized immediately. The thinking is, maybe the information is somehow encoded in the radiation that comes off this process.
But wait, the video said this contradicts Einstein's idea that falling across the horizon should feel like nothing special, not like hitting a blast furnace.
That's the conflict, exactly. The firewall solves one problem, maybe preserves information, but it seems to break a fundamental principle of general relativity. It shows just how tricky these concepts are. We're really pushing the boundaries of what we know.
Okay, so maybe not a fiery end. What about the other really out there idea the video mentioned, the white hole theory? Sounds very sci-fi.
It does have that vibe, definitely. But it actually comes from some of the math in Einstein's theory. A white hole is like the opposite of a black hole. Instead of pulling everything in,
it spits everything out.
Violently, yeah. Like a cosmic fountain. The idea is maybe the singularity inside a black hole isn't an endpoint, but a connection, a tunnel.
A tunnel to a white hole, like a wormhole.
Potentially, yes. Some highly speculative theories suggest a black hole could be one end of a wormhole connecting to a white hole somewhere else. Maybe even in another universe or another point in time.
Whoa. So falling in wouldn't be the end, it'd be transport.
It's a possibility, at least theoretically. The information that falls in might get ejected out the white hole end, maybe in a totally different reality.
That's properly mind-bending. Falling into what seems like oblivion and ending up somewhere entirely new.
It's an incredible thought, isn't it? And the video pointed out it kind of fits with the quantum idea that information isn't destroyed, it just changes form or location. Maybe it's not lost, just relocated.
Which seems like a good place to talk about quantum information itself and this holographic principle idea. This sounded like a potential key.
A lot of physicists think it might. The holographic principle basically suggests that all the information about everything that falls into a black hole, it doesn't actually reach the singularity and it's not destroyed. It gets sort of imprinted.
Imprinted where?
On the surface of the event horizon. Like all the details of a 3D object falling in are encoded onto that 2D surface.
So even if my body is, spaghettified or crushed, the information about me, my atoms, my structure, still exists as a pattern on the black hole's boundary, like a cosmic hologram.
That's the idea, yes. Your physical form might be gone, but your fundamental information, your essence, persists on the event horizon. Some people even take it further and suggest our whole universe might be a hologram projected from some distant boundary.
Okay, wow. So black holes aren't just destroyers. They're maybe cosmic hard drives, storing information in this incredibly strange way.
That's a fantastic analogy. They might be preserving the information even if the physical object is annihilated. It really makes you question what destruction even means at that level.
The video also kept coming back to time dilation. That's another thing that just feels so counterintuitive. How exactly does falling in warp time?
Well, Einstein's relativity tells us that gravity affects time. The stronger the gravity, the slower time flows relative to somewhere with weaker gravity.
Right.
So as you fall towards the black hole's immense gravity, your clock would tick slower and slower compared to someone far away.
And that's where the video's example came in. Like years or even centuries could pass outside while only moments pass for me.
Exactly. You might experience your fall as taking, say, a few seconds or minutes, but in that time, eons could have passed in the external universe. You could, in theory, watch the future of the cosmos unfold in fast forward.
That's profound and slightly terrifying. It makes you wonder what time even is.
It certainly challenges our everyday assumptions about a universal clock ticking away steadily. Gravity makes it relative, flexible.
Okay, so all these threads seem to lead back to the singularity, this infinite point where, like you said, our two best theories of the universe, relativity and quantum mechanics, just don't agree.
Precisely. General relativity predicts this point of infinite density, crushing everything. Quantum mechanics says information can't just vanish like that. The holographic principle is one attempt to sort of bridge that gap. Maybe the info stays on the surface.
But we don't have the final answer yet.
No, not even. Finding a theory of quantum gravity that unites the two and explains what really happens at the singularity is maybe the biggest goal and fundamentals right now.
And one last thing, the video covered Hawking radiation, the idea that black holes aren't perfectly black.
Right. Stephen Hawking's amazing discovery, he showed that due to quantum effects right near the edge, the event horizon isn't perfectly quiet. Tiny pairs of virtual particles pop into existence.
Virtual particles.
Yeah, they exist for fleeting moments. Usually they just annihilate each other. But near a black hole, sometimes one particle falls in and the other escapes.
And the escaping one carries energy away.
Exactly. It looks like the black hole is emitting a faint radiation Hawking radiation. And because energy is mass equals mc squared and all that, the black hole slowly.
So they evaporate over cosmic time.
Over incredible timescales, trillions and trillions of years, yes, they should eventually evaporate completely.
But then, what happens to the information? If the black hole disappears, does the information disappear with it?
And we're right back to the information paradox. Does the information get encoded somehow in the Hawking radiation as it leaves? Or is it truly lost when the black hole evaporates? It's another huge unanswered question.
So, wow. If you fall in, you could be stretched into spaghetti, crushed infinitely, maybe vaporized by a firewall, potentially thought out into another universe, or perhaps your essence just gets stored as information on the surface, only for the black hole to eventually radiate away, maybe taking your info with it, or maybe releasing it somehow.
That pretty much sums up the bewildering range of possibility. As the quantum wisdom video really highlighted, we just don't know for sure yet. And honestly, that mystery is a huge part of why black holes are so fast.
It absolutely is. It forces you to think about these incredible extremes. Could these things we see as ultimate destroyers actually be like fundamental keys to understanding reality, information, maybe even pathways to other places or times?
It's a wild thought.
It leaves you wondering, doesn't it? If information really is fundamental and can't be destroyed, what does it mean for it to be captured, stored, or maybe even transported by these cosmic enigmas?
Something to ponder.